Sir, can you once explain the concept of fault equivalence?
Oh, fault equivalence. Okay.
Yes, sir.
So also there was a small question that I had.
Hmm.
So in practice in graded, we typically find a lot of MCQs. However, the
Hmm.
ones that you've covered in the lecture, that is more problem oriented, which is with
Hmm.
respect to it being more subjective. So if you want to like practice more of such questions, so
Hmm.
do you recommend we just rewatch the lectures, or how do we go about it?
If you have followed those lectures, I think you will be okay. I don't think you should worry so much, right? You can practice the same problems that are there in the lectures, or you can make up your own problems. If you want me to suggest a problem, I can suggest for you. Okay. So let us look at. Okay, so if you have a gate. See, the stuck at zero fault on A will result in the output, becoming equivalent to zero, right? So if A is stuck at zero, the output will, have a zero. In the same way, if B is stuck at zero, also the output will be zero. Finally, if C is stuck at zero, then also the output is zero. So that is why we say these are all equivalent faults. So A0 and B0 are equivalent, and they are all equivalent to one another. Is that clear? So equivalent fault is a very simple concept. So two faults are equivalent if in their presence the circuit behaves in the same way. Okay. So for example, let us take this fault. So suppose A is stuck at zero, then if A is stuck at zero, the output of the circuit is 0 plus D, or E will behave as D. Similarly, if B is stuck at 0 also, it will behave as D. If C is stuck at 0 also, it will behave as D. So all these faults are equivalent. That clear?
Yes, sir.
Yeah.
So basically, if we are applying some test vector and if it is detecting all these events, then it's known as fault equivalence.
No, 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 I didn't say that. See, you take A0. If you pretend that A is at 0, what will be the output at C? 0. 0 plus D will be E. So the output will be D. You agree?
Yes, sir.
Similarly, if B is stuck at 0, what will be the output? The output will be D. If C is stuck at 0 also, the output will be D. So the circuit's behavior is the same for all the three faults. So A is stuck at 0, B is stuck at 0, and C is stuck at 0 are all same.
Yes, sir.
Yeah.
Got it.
What else? Can you tell me any other equivalent faults here?
C stuck at zero, D stuck at zero.
Yeah, those I have already mentioned. Any others? See, C1 and D1 are equivalent, right? So if C is stuck at 1, the output will be 1. If D is stuck at 1 also, output will be 1. Similarly, if E is stuck at 1 also, the output will be 1. So C1, D1 and D1 are also equivalent faults.
Yes, sir.
Yeah. All right.
Sir, fault equivalence does not mean that the test vector of that uh, fault is also equal. Like
Uh,
the test vectors may be different.
so yeah, you're right. The test vectors for these faults will not be the same. But the point is, you cannot distinguish between them. Okay, you
Yes,
cannot tell them apart. Okay, if A stuck at 0 occurs, or B stuck at 0 occurs, or C stuck at 0 occurs, the output will be E. I'm sorry, output will be D. Right?
yes, sir.
See, what is a test vector for A stuck at 0? We have to activate the fault, so that means we have to make this one. We have to propagate the fault, so we have to make this one.
Yes,
Right?
sir.
And the fault will propagate here, right? And we have to make this 0. Okay.
Yes,
Similarly, for B stuck at 0 also, this we have to activate the fault by placing 1. We have to propagate it by putting a 1 here, and we have to propagate the fault to output by putting. So 110, if I apply and find that the output is different. See, a good circuit will take 110 and produce 1 here, right? Whereas if there is a fault, either A0 or B0 or C0, the output will be 0, right? So if I apply 110 and find that the output is 0, then any one of these faults could be present. It could be A0 or B0 or C0. We will not be able to find out which one because they
yes.
are equivalent faults. What is a test vector for C stuck at 1?
So 0 and 0.
See, to activate that C stuck at 1, we should put a 0 here. So either of these can be 0, right? It could be 0,
Yes,
0
sir.
or 0, 1 or 1, 0. And to propagate the fault, we need to produce a 0. So
So,
all these are vectors. So 0, x, 0, 0, x, 0.
So maybe more like 0xx or maybe x0x.
Any one of them can be 0. So x 0, 0. Okay. So 0, 0, 0 is a test vector, 0, 1, 0 is a test vector, and 1, 0, 0 is a test vector. So there are 3 test vectors. We agree?
Yes, sir.
0, 0, 0, 0, 1, 0, and 1, 0, 0. Correct?
Yes, sir.
No, wait. Yeah, right. 1, 0, 0. Yeah.
So which is the third branch?
0, 0, 0, 0, 1, 0, 1, 0, 0. Right?
So which is the third branch? Because I see that A and B are the two branches, the initial two. Which is the third one? Is it D?
What is a branch? I don't understand.
I mean
See,
the input vector
Yeah,
where.
D.
this is C. This is C.
Okay, okay.
I by mistake. No, no, wait. This is D, and this is C. A, B, C, D, E. Right. So if I apply one, uh, I'm sorry, if I apply 0,
X.
1, 0, a good circuit will produce a 0, 0. Whereas if that fault exists at C, it will produce a 1. Right?
Correct.
Yes.
Yeah. Similarly, let us do it for D stuck at 0. I'm sorry, D stuck at 1. So this is my C, this is my D. If you want to expose D stuck at 1, we have to apply a 0 here, right? And in order to propagate this fault, this also has to be 0. So again, it can be 0, 0 or 0, 1 or 1, 0. So the test vectors are 0, 0, 0, 0, 1, 0 or 1, 0, 0. So C1 and D1 are equivalent because the same vectors. You understood, no?
Yes, yes.
Any others?
So, sir, regarding the pattern of the question paper, uh,
Mm-hmm.
what can we expect?
There will be some questions of this type, like find a test vector, or whether a particular test vector will catch a particular fault, or I may also ask you to briefly explain. So when I say briefly explain, I'm not expecting more than 2 or maximum 3 sentences. So please don't write long, long paragraphs, right? So just explain it in 2 or 3 sentences maximum. So there may be questions which may be, define something, or fill in the blank, or maybe true or false, right? But true or false, you have to give an explanation. Okay. So why is it true or why is it false? More questions?
Sir, no, sir. I think understood for the most part. We can expect true, false, maybe questions wherein we have to explain with a
Right.
one two liner, and then these test vector finding questions that you just
Yeah, yeah. Anybody else has any questions?
Sir, one request, if that can be considered, can we please get like a 10 question or let's say a 15 question practice sheet before the exam? Because once
No,
you
no, no, no. No, I don't plan to give any practice. You have already practiced, no? See, all these questions that we have been giving, if you
uh,
have done it yourself after thinking about it, I don't thi- the idea of practice quiz was not to put it in chat GPT or ask somebody else and fill it. Okay,
Yeah,
it
yeah.
was supposed to be a practice. So if you have been doing those, I don't think you should worry. See, if you are
Yes, sir.
giving it all to Chat GPT and just writing the answer, then obviously this will not work.
Right, right.
So there is no point in giving more questions. The practice questions, if you have done it on your own, then you have prepared.
Yes, sir. That and also all of the questions that you had, asked in the lectures, I have gone
Yeah.
through.
So please do it yourself. Okay, don't depend on Chat GPT or something like that.
Certainly. Yeah.
See, in IITs, we don't give all these things. Okay, we don't give mock tests and prepare you to. That is not the style of IIT. Okay.
Sir, I have one question. It might be irrelevant to today's discussion. Can I ask
Uh,
it?
Tell.
Sir, so basically, in the later weeks, you have discussed the scan register, right?
Hmm.
So in that, you have given that when we are feeding in the test vector,
Hmm.
or else the value, whichever we want the state it to be, we are
Hmm.
using an mux and muxing it with a serial in serial out.
Yeah. Everybody has watched these scan videos.
No, sir, no, sir. They haven't been out yet.
No. Okay. So I suggest we wait for them to watch. No, otherwise they will not understand.
Okay.
Next week, I think you can ask because by then they would have watched.
Okay. The problem is I thought I might forget, so I asked, sir.
So you note it down. I asked me
Okay.
later.
Okay, sir.
What is the question anyway?
So basically, what's my doubt is there we are keeping serial in serial out. Why can't
Hmm.
we just keep a parallel in parallel out, mux it with so that it will be much faster, right?
Uh, there is something called as random scan.
Okay.
People do use it, but it
Okay.
requires a lot of pins, extra pins, which is very difficult. So
Okay.
pin limitation is the reason why we only use serial in serial.
Okay.
Yeah.
Yes,
There
that
is
makes
something
sense.
called as random scan.
Okay. Okay, sir. Got it. Thank you.
Yeah. I'm open to any other questions that you may have. You want me to explain something that you have not understood? Feel free.
Sir, in fault dominance,
Hmm.
we have a lot of test vector for a particular fault, but we choose only one of them
Hmm.
fault vector that is also suitable for other fault detection. That is
Yeah.
called fault dominance.
Yeah. Same. Let us take the example of a AND gate only.
Yes.
So suppose A, B, and C are the pins. So tell me what is the test vector for A stuck at 1?
Uh, 0 and 0.
See, if you want to test for A stuck at 1, to activate the fault, you have to put a 0. And to propagate the fault, you have to put a 1, right?
Uh, yes, sir. Sorry.
Yes. So 0, 1 is a test vector for A stuck at 1. By symmetry, you can, see that B1 will be a test vector for 1, 0, right? I mean,
0 and 1.
what about
Sir,
C? What about C1? See, if you are worried that C is stuck at 1, you have to put a 0 here. That can be done by placing 0, 1
and 1 0.
1, 0 or 0, 0. You agree?
Yes, sir.
Any one of these will be a test vector, right?
Yes, sir.
So if you have included A1 in your fault model, this it will test C1 also.
Yes, sir.
I'm sorry, this one. Okay. Similar, or if you have included B1, that will take care of this. You understand? So
Yes,
if
sir.
you have included either A1 or B1, that will take care of C1. So there is no need for you to separately test for C1. So we say C1 dominates A1, C1 dominates B1. You understood?
Yes, sir.
The set of tests for C1, if you look at it, this one is a subset of it. So the test set for B1 is a subset of the test set for C1. So if you include B1, there is no need to include C1. Similarly, if you include A1, you don't need to include C1. So we say C1 is a dominant fault and we can remove it. Okay?
Yes, sir.
Yeah. So if you have many equivalent faults, you can retain one of them and remove all the others. Similarly, if one fault is a dominant compared to the others, the dominant fault can be removed. Okay. Now you try this. So suppose I give you an OR gate. Suppose I call this X, Y, and Z. Okay. Which one is a dominant fault here? Okay. Try Z1. I'm sorry, Z0. If you want to test for Z0, you have to place a 1 here, right? So that can be done with either 0, 1 or 1, 0 or 1, 1. All these three will work. Then look at X. Let us say we want to look at X 0. If you want to test for x0, you will place a 1 here, and to propagate the fault, you will put a 0 here. So 1, 0. So you will notice that the test vector for x0 is a subset of the test vectors for z0. So z0 is a dominant fault. So we can remove it. Is that clear?
Yes, sir.
Yeah. Is there any confusion? Why did you say it is 0, 0? I don't know why you said 0, 0. When I
Sir,
want. Okay.
it's my fault, sir.
Okay. If there is any confusion, let me know. If it was a sort of a silly error, then I can understand.
Yes.
Sir, I have one
Hmm.
conceptual question. So,
Hmm.
when we when we study the checkpoint theorem,
Hmm.
we assume that if we consider the faults at
Correct.
the primary inputs and the fan outs,
Yes.
that's fine. Is there any intuition why this is true?
It is based on these theorems only. This dominance and equivalence. Okay.
Okay, best.
Yeah. The theorem is proved by using this equivalence and dominance only.
Okay, sir.
Yeah.
So basically, then if you write test vectors for that, it's enough.
Yeah. In this AND gate, it's enough if you test for A0, A1, B0, B1. So if you do this, that is enough. We don't need to separately consider C0 and C1 because C0 is equivalent to A0 and sorry. So it's enough to consider A0, A1, B0, B1 because C0 is equivalent to B0, so it need not be considered. And we just showed that C1 is dominant and it is, if you have taken care of B1 or A1, the other is not required. So the checkpoint theorem says that these four are enough. Okay. In fact,
Yes,
you
sir.
can also remove one more. So three are enough. Okay.
Yes.
But checkpoint theorem will not get into that. Okay. Its main purpose is to avoid, you know, to say that all the
Unnecessary.
primary inputs and fan out branch are absolutely necessary. You may further be able to eliminate a little bit more by using equivalence. Okay.
Yes.
Yeah.
And sir, so once maybe it's a silly doubt, but in text vector, let's say that there is a three input combinational block,
Hmm.
and one of the test vector we wrote is x01.
Hmm.
Then can we consider this x01 as a test vector or 101 and 001?
No.
So,
If you have x01 as a test vector, it means that there are actually two vectors.
so
So
basically
if
it
you
means two
have,
test vectors.
yeah, either one of them will work. So any one of them, 001 or 101.
Yes, sir.
Yeah. In reality, you have to apply one of them. So whether you choose 001 or 101 is up to you.
But we should consider it as two test vectors.
Yeah, right. I mean, if let us say, suppose I am looking for a fault here, right? Let us say stuck at 0 fault here. So to activate it, I'll put a 1. To propagate it, I'll put a 1, right? Now the fault has come all the way here. To propagate it further, I have to put a 0. So I can put either 0x here or x0 here, right? So there are actually how many vectors? 0, 0, 1, 1, right? 0, 1, 1, 1, and 1, 0, 1, 1. So there are three vectors. All of
Yeah.
them will work, right?
Okay.
So you will take one of them.
Hmm.
So frankly,
But
what happens is, see, suppose you have several faults, you will say for, let us say, fault F1, you have selected, let us say, 0x11. Okay. And there is, let us say, another fault F2, where the vectors are, let us say, x0 x1. Okay. Now you can look at these and say that, I can put 0 here, I can put 0 here, I can put 1 here, and I can put here. So if I pick 0 0 1 1, then it will catch both F1 and F2. Is that okay?
Yes, sir. Yes, sir.
So that is what people will do. The test tools, they will not, as soon as you find 0x, 1, 1, etc., they will not immediately convert x's into zeros. So they will keep all the test vectors, and then they will do this, what is called as fault compression. So if I don't compress, then I may end up with so many faults. I may say 0 0 1 1, right? And 1 0 1 1, right? So unnecessarily I'll generate two vectors, but a single vector will catch both of them.
So basically, what we are trying to do is just to say if that particular chip or IC is it faulty or not. We are not trying to jot down what is the fault.
No, no, no. We are only interested in just rejecting the badge. We don't
So
know.
go no go testing.
That's all. That's all.
So this is what we call as diagnosis.
No, no. Diagnosis is the opposite. Diagnosis
Okay.
means you will have to find out what the problem is. It's just like you go to a doctor, he will diagnose what the problem is.
So we'll jot down to one fault.
Hopefully, one. You may not always be able to
Oh,
just
okay.
see. You may be able to tell these are the three problems that may exist, or five problems. So that is the resolution. Okay. See, if let us say I, there can be, let us say, 16 different faults in the circuit, and based on the testing, I think either one of the three could be present, right? Then I have been able to resolve it to 3 out of 16. Within that 3, I don't know which one is there.
Yes, sir.
Yeah.
Okay. We might jot down to, okay, we might not say, okay, which of the three are present or something like that.
Right, right. See, suppose you go to a doctor and you have he looks at the symptoms, right? So the symptoms and any tests that he may ask you to do, based on that he can possibly, one of the two may be there, right? Maybe you have an allergy or something, or maybe you have some other, So there are two, let us say two things that are possible. So to further figure out what is the actual problem, more tests are needed. Okay, so more tests will help you to resolve better.
So that is diagnosis resolution.
Yeah, yeah. We want diagnostics to finally resolve it to only one of the faults, but that is not
Okay.
possible, as I told you, right? You
Yeah,
can't
yeah.
resolve. Yeah, for example, if equivalent faults are there, right, you cannot ever resolve. See, if
Yeah.
I find that there is a fault, I apply 0 1. I was expecting a 0, but I saw a 1. Right? What could be the problem? It could be because C is stuck at 1, or it could be A is stuck at 1. Both of them, any one of them could be present.
Yes, sir.
So I
And
won't be able to resolve.
yes, sir. Sir, and this redundant faults. So basically, we can consider this redundant faults as the don't care conditions in the combination logic. So wherever we have a don't care condition at an input, we can say that even though there's a fault at that input, it won't be shown at the output. So that is a redundant fault.
No, no, no. Redundant fault means somebody did not optimize properly.
Oh,
Okay. See, in Karnaugh maps, right? If I take this Karnaugh map, suppose I have a 1 here and a 1 here and 1 here and 1 here. Okay. So you could take these two guys, okay, and you could take these two guys. Now suppose somebody took this also. Okay. There is nothing wrong. It will work, right? But it is there is some redundancy in the circuit. This term is redundant. So there will be one term which is, let us say we call it as A, and these are BC. So this term will be A bar. What is this? 0001, right? And 1 1. So this term is A bar C. Correct? You agree?
Yes, sir. Yes, sir.
So this is 00 01 11 and 10. So somebody figured out this is A bar C plus this is A B. And they also included one more term, which is let us say BC. So this term is redundant. It's not required. So if there is a fault on one of these this AND gate, for example, let us say the output of this AND gate is stuck at 0. It is not going to matter. You understand, no?
Yes, sir.
If the AND gate that produces BC is stuck at 0, there will be, you cannot tell that output, right? There is no test vector for that, because this is A bar C plus AB plus 0 is same as A bar C plus AB plus BC.
And also, we can
Because
say it doesn't even matter for us, right? Even though if that fault exists, we don't lose anything.
you are right, but it is important to catch that fault, okay, because
Yeah.
it says something about the uh, see, if that fault is there, right, it is something like this. See, many times our body has some some immunity, right, because of which, even though there is a we may have a problem inside, but our body sort of masks it in some way, and we don't realize the problem. But if you let it go on like that, then a time when will come when we will have serious form. So it's a reliability issue. Okay. So for that reason, it is better to catch that redundant fault. Whatever is causing BC stuck at 0 to happen may also ultimately cause this also to fail. Okay? So even though there is a redundant term, it is important for you to test for that thing. Okay.
Yes, sir.
Yeah.
Sir,
Sir,
Hmm.
sir, in previous example,
Hmm.
where you take stack at fault 0
Hmm.
and you give 1 as a like to activate that fault.
This one, huh?
No, sir, below 1.
This one. This one.
Yes, sir. Yes, sir.
Okay. Okay.
Okay, sir. For example, if that AND gate does not have a fault, then it should give 1 as output.
If I apply, yeah, that's right. That's right. And if
Yes,
it
sir.
has a fault, then it will give 0, 0. It will give 0 as output.
But sir, but if we want to propagate that fault, then we have to give uh, uh, 1 to the second AND gate. Because if does not have a fault, then it should be given as a 1 to the final output. And it is possible only if we give a 1 as a input to the final AND gate. But here we give 0 and x, so it may be 0 0, then the output of the first AND gates is 0, and the
No, no, no. Wait,
below AND
wait,
gate.
wait, wait. No, let us figure out, right? See, let me
Yes, sir.
redraw the circuit. So here I am worried that there is a stuck at fault here, stuck at 0 or something like that, right?
Yes, sir.
So I will activate it by putting a 1.
Okay, sir.
Correct?
Yes, sir.
Now you are saying I should put a 0 here, is it?
No, no, sir. 1.
Then where? Okay. So if I put a 1 here, the fault will come here. And to propagate that fault here, I have to put a 0. You agree? See, if I put a 1 here, both the good and the bad circuit will give me a 1, right? So I
Yes,
have
sir.
to put a 0 here. So that 0 can be obtained by either 0x or x0. If any one of the inputs is a 0, then I will. So the vectors are 0, 0, 1, 1, 0, 1, 1, 1, and 1, 0, 1, 1. So there are three vectors that will catch this particular fault.
Yes, sir.
Correct, no?
Yes, sir.
Yeah.
But sir, if that AND gate does not have any fault, then it also gives 0, na sir? Because that AND gate give us 1, because we give 1 1, and then the output of second AND gate is 0. So 0 and 1 also gives 0. So faulty circuit final output is also 0, and circuit of normal circuit final output is also 0. Then how we can
No, no, no,
distinguish?
no, no, no. Think about it. See, suppose there is a fault here. This AND gate will produce 0, right?
Yes,
This is
sir.
already producing a 0, so the output will be 0, right? Whereas if the circuit is good, 1 and 1 will produce a 1 and the output will be 1. See, a good AND gate will produce a 1.
Yes,
A
sir.
bad gate will produce a 0.
Yes, sir.
Here, both the circuit, good and faulty, will have a 0.
Yes, sir.
So here the output will be 1 or 0. A good one will produce
Okay,
a 0.
okay, sir. I confused because I think that final gate is a AND gate.
No, no, this is OR gate.
Okay, okay, thank
Okay. Yeah,
you. Yes,
you have to be, little bit. Sometimes, our mind works like that.
yes, sir.
Sir,
Yeah.
do we add redundancy intentionally to avoid hazards?
Yeah, yeah. We can add in. There are many reasons for making redundancy. One is, to remove hazards. The other could be for, like to tolerate faults. Okay. So you add, suppose I want to be absolutely sure that there is no problem, right? I may, uh, suppose this is my logic. So there is some logic that I want to compute, and I'm worried that if it develops a fault over a period of time, there is a problem. So I may duplicate that whole thing, okay, or I may even make it 3 times, right? And I may take some sort of voting circuit here. So this will be the majority. So if one of them is producing 1 and this is also producing a 1, but this is producing a 0, then this will produce a 1, saying that the majority of 110 is 1. Okay. So they are identical circuits and they should ideally produce all ones. But because of some fault, this guy is producing a 0. Okay. So we try to take the best 2 out of 3. So it's like when you are verifying your results in the exam, first time, let us say you got 2.3 as the answer, right? Then before giving the exam, you will try to verify it. And this time you got 3.2. Okay. Then you panic. Then you say, hey, what is going on? Then you'll do it again. This time you got 2.3. Okay. Then you'll say, okay, I maybe this went wrong. So 2.3 is the correct answer. Okay. So that is how you will do. Right?
Yes, sir.
So there is a lot of redundancy in the circuit. The same thing has been duplicated.
Yeah, yes, sir. Sir, could you also once explain in brief about the tie cells undetectability?
Tie cell means, see, um, suppose I have an AND gate which is 3 input. I want to use it as a 2 input NAND gate. Right? So then I will tie this to a 1. Okay. And I will use, let us say, A and B. So this is going to produce AB bar. It will act as a 2 input NAND gate. But there is some, this. So if there is a stuck at 1 fault here, we will not be able to tell. You understand, no? If
But
there is
sir,
stuck at
maybe we
1,
can put one on the A and check for C
no, it
stuck
has
at
been
one, right?
tied off, man. It has been connected to VDD permanently.
Oh, okay, okay. We can't change that.
No, we can't change it. It's been connected permanently to 1. So if
Okay.
there is a stuck at 1 fault there, we will not be able to tell. And the same reasoning applies. You can say, how does it matter if it's stuck at 1? We want it to be 1. The point is, if there is a reason that causes it to become stuck at 1, ultimately these two also may get affected by that. So we should not, let that go. Okay? We should not. There is some manufacturing error which is causing that to happen. So we should catch it and declare it as a fault. Okay.
So sir, we can't add any extra wires to extend it to make it more observable also, is it?
No, no, no. We don't have any way to do that, right? I mean, this is connected permanently to 1, so I don't see how we can test it. We have to
Okay.
just, we'll remove that from our list. We'll say we are not going to worry about the stuck at 1 fault here, so we'll just drop that.
Okay, sir.
Okay. If you have understood these concepts wisely, don't worry at all. You can just not worry so much about the exam per se. The purpose of giving an exam where you have to write etc. is because that is how your interviews and all will be, right? Tomorrow if you appear for an interview in a company or something like that, see, they are not giving you mock questions ahead of time, things like that, and they expect you to answer it's not going to be objective or anything like that, right? So it's better you know answer these subjective questions also. Okay. Anything else before we break?
Sir,
Hmm.
characterization and validation, which is usually done first.
See, the first thing will be, I believe validation, because first thing is to see whether this product is really what we want, and then when we are sure, we will want to, understand its performance and everything in very great detail. So then we'll go in for characterization.
Yeah, yes, sir.
Suppose
But
we
sir,
don't even
in
want to release a product. Okay. Validation engineers are, let us say, rejecting that product. Okay. And there is no point in characterizing it. You understand, no?
yeah, yes, sir.
Yeah.
Yes, I too had the same intuition,
Correct.
but one of the graded assignments, I think it's given in the reverse order.
Is it? Okay. All right. So the validation is usually done first.
Yeah, sure, sir.
Yes, in graded assignment 1.
Mm-hmm. Okay.
Sir, we validate our product according to the customers, and then on that parameters, we characterize that product, like on different parameters, according to the customer's expectations. Is it true,
Yeah,
sir?
I mean, you may have seen data sheets of products, no? Right? If you
Yes, sir.
see any of the ICs that you buy, it comes with a data sheet. That data sheet will have all those things like what is the slew rate at different temperatures, how does it do, all that detail will be there, right? So all that is done through characterization. To publish the data sheet, you will need to do all those characterizations. Understood, no?
So these questions, the ones from week 1 particularly, they can show up in like 1 or 2 liners and MCQs. Am I right?
Yeah, it could be like that. Yeah.
I see. Okay.
Yeah, I'm not saying it will be from the practice questions. No? I did not look at those when I made up these questions.
Yeah,
But
yeah,
I mean,
yeah,
there is a
sure.
chance that there is some overlap. But I didn't design it that way.
Sir,
Yeah,
production testing and manufacturing testing. So do they mean
they're the
the same
same.
thing?
They're the
Is
same.
it?
They're the same.
And this test is the only one which is done on all the products,
Yeah, right.
not just on the specimens.
No, no.
Yes, sir.
Okay, guys. So wish you all the best for your thing. Don't worry so much. Okay, take it easy. You will
Thank you,
find
sir.
it quite easy only. There is nothing. You do it. 60 minutes will be given to you. right? I think there are 4 questions or something like that. That's what I remember. So it should not be 4 or 5. I don't remember. Each are just 1 marker, etc. So there is plenty of time. To my knowledge, time is not going to be such a big issue. So take it easy. Nothing so difficult or anything. Okay.
Right, sir. Thank you.
All right. All the best to you.
Yeah, thank you, sir. Have a
Thank you,
great
sir.
day. Bye bye.